Okay, so sometimes we're going to see integrals that have the natural log in them already, and we have to figure out what we're going to do with those. So let's look at this first one, and we're going to do a U-substitution here. So, okay. So what we think about is we see this natural log of x, and so we see a function and its derivative, right? Because the function is ln of x, and its derivative is 1 over x. So I see a function and its derivative, which tells me I need to do a U-substitution with the function. So I let u equal natural log of x. That means du is going to equal 1 over x dx, which means dx equals x du. Okay, because I just multiplied both sides by x to undo that. And then everywhere I see dx, I can just put in x du. You might have seen right here that I have 1 over x dx, and I could just replace that in here with du. But if you don't see that, that's fine too. Okay, so we're going to replace, this is going to be the integral of u over x du, x du. Okay, and the x's cancel out, and so I just end up with the integral of u du. And we know how to integrate that, so that equals u squared over 2 plus c. And then we just need to substitute back in our ln. So we bring our u back in, and we have ln x squared, because that was our u, over 2 plus c. So you might rewrite this as 1/2 ln x squared plus c. That is really ugly, so let's try that again. Plus c. There you go. And you're done. So let's look at the next one. You have the ln x in there, and again, we see a function and its derivative, which makes me think that we are probably going to be doing a U-substitution. All right, there we go. I accidentally pushed too far over. Okay, so let's do a U-substitution here. So we're going to let u equal 2 minus ln of x, because I see a function inside of a function. That's the other thing that I think of when I do a U-substitution. And then that means du equals negative 1 over x, because the derivative of ln of x is 1 over x, and it's negative, so it's dx, which means dx, if I just multiply both sides of the equation by negative x, it's going to cancel it out, so I have negative x du. Okay, so now I can do my U-substitution. This becomes u, all right, so I have the integral of 1 over x times u cubed, and then everywhere there's a dx, I'm just going to replace it with my du. Okay, and then I notice that this x and that x cancel each other out, and I'm left with the integral of negative 1 over u cubed du. Okay, now since there's a negative 1, I can pull that outside my integral, so that's negative 1 times the integral of, and I'm just going to rewrite this as u to the negative 3 du. And then I can go ahead and integrate that, and that would be negative u to the negative 4, not negative 4, sorry, negative 2, see I made that mistake, over negative 2, but we add 1 to negative 3, which gives us negative 2, plus c, and so negative over negative gives me a positive, so I have u to the negative 2 over 2 plus c, and then I can rewrite this. Let's see, I got to put my u back in, so we're just going to go ahead and write this as 1/2, and then u was 2 minus ln of x to the negative 2 plus c, and you're done. And you could rewrite that in whatever format if you want to put it in the denominator, or, whatever, but that's that. Okay, last example here is a little bit of a challenge, so just bear with me. Now that I say that, you guys are all freaking out. Okay, so, see, I keep going to the next page, but it's really just right here. Okay, let me clear all this ink off from here. There we go. All right, So we're going to integrate this. And it doesn't really give us like an idea. When we first look at it, we don't have a natural like substitution because it's not like a function in its derivative. But I do see 1 over something, which makes me think there's maybe some natural log involved in here. So let's just get started. So the first thing we're going to do is we're going to do a U-substitution, and we're going to call U square root of x, okay? Then we're going to say our derivative of that would be 1/2 x to the negative 1/2. Okay, hopefully that one is pretty standard for you, dx. Which means that dx is equal to 2x to the 1/2 du. Okay, because I multiply both sides by the reciprocals of this, because this is really 1 over 2x to the 1/2. In fact, we'll just write that as a square root because it's easier to see. Okay, so it's like that. And we multiply both sides by the reciprocal, and I end up with dx equals 2 times square root of x du. Okay, so I'm going to substitute this in. So I've got the integral 1 of u minus 1 to square root x du. And you say, well, that didn't help me any because it didn't actually get rid of anything. Well, it did and it didn't, because do you see this right here? Look, square root of x is u. So we can just substitute that in again. Okay, so now I have the integral of 1 over u minus 1 times 2u du. And I'm going to go ahead and bring that 2 outside the integral because it's just a constant. And then I'm going to have u over u minus 1 du. And again, you say, well, that didn't get us anywhere. Well, we now have a function over a function, and they have the same degree. So we can't use the ln just yet, but we could use long division to be able to give them the same, like split them into 2 fractions so that the bottom now has a higher degree than the top. And then we can do another u sub possibly, but I don't think we're going to need it. Okay, so we're going to use long division, and we're going to say u divided by u minus 1. Well, u goes into u 1 time, and that gives you u minus 1. And we subtract this, we end up with positive 1 down here. So our remainder is positive 1 over u minus 1. So again, I'm telling you, this right here is the same as that. They are the same function, okay? So then I rewrite it. 2 times the integral of 1 plus 1 over u minus 1 du. And now we actually know how to integrate this. This isn't so bad, right? So we can split it. So it's 2 times the integral of 1 is just u, plus the integral of 1 over u minus 1 is ln of the absolute value of u minus 1. And then, you could potentially have looked for like a chain rule thing, but we don't need to because the derivative of u minus 1 is 1. So there wouldn't be a chain rule issue here. Plus c. And then we've got to get this back in terms of x. So we know that u is square root of x. So we just sub that back in. Square root of x plus ln absolute value square root of x minus 1 plus c. And then we have 2 root x plus 2 ln absolute value square root of x minus 1 plus c. And we're done. Okay, so that wasn't as bad as you thought, right? I hope not. That's all for integrating logs.